Hello, dear students. As you know, we are dealing with the numericals of the chapter Current Electricity. I hope all of you are doing good at this. For me, I am feeling them as interesting. I don't know what about you. Hmm. Try to enjoy the problems like they are not much boring like the theories. Okay, so moving on. In the last class, we have solved the problems up to the year 2017. Up to the question paper of 2017, we have solved the problems. Now, moving on to the next one. So, here I got the questions from the year 2016. Okay, as you know, we got theory questions, and in the 5 mark, we got 37th question as a numerical problem of the from the 2016 question paper related to current electricity. Okay, so see here, they have divided the problem in the subsections like A and B. Okay, so let's see it, what is the question. So in the 37th question, we have the question A as 3 resistors of resistance 2 ohm, 3 ohm and 4 ohm are combined in series. What is the total resistance of the combinations? Means 3 resistors 2 ohm, 3 ohm and 4 ohm are combined in series. So here we have to find the total resistance of this combination. It's very easy, very simple problem. I hope you can analyze the problem. And continuingly, they have extended the question to the subsection B as if this combination is connected to a battery of EMF 10 volt and negligible internal resistance. Obtain the potential drop across each resistor. Try to understand the problem first. See, let us analyze the problem first. What they have given here, they have first, in the first what they have given, 3 resistors of resistances 2 ohm, 3 ohm and 4 ohm are connected in series. So first let analyze the subsection A first. What they have asked, see here, they have asked, see 37 question number A. First analyze the problem. What they have given, 3 resistors. 3 resistors, 1, 2, 3. 3 resistors of resistances 2 ohm, 3 ohm and 4 ohm are combined in series. Now, what is the total resistance of this combination? Hence, it is in the series combination. You can find the total resistance very easily. So, what will be the total resistance? You know the formula for the total resistance in series, R1 plus R2 plus R3. So it is very simple. What is RS? 2 plus 3 plus 4. RS is 9 ohm. So it becomes the question number A, subsection A. So how you have to solve it? You have to draw the diagram first. You have to write the formula, because hence it is a very small question. In the given, you only have the diagram, and what is there to find? What you have to find? You have to find RS is equal to what? And what is the formula you have for this? For the formula, RS is equal to, you have R1 plus R2 plus R3, because in the series combination we have the formula like sum of the individual resistances. So what are the individual resistances we have here? 2 ohm, 3 ohm and 4 ohm. So what is in the calculation? In the calculation you will get only RS is equal to 2 plus 3 plus 4. Hence RS is equal to 9. So in the result, what you have to do? You have to write RS is equal to 9. What is there next to 9? The unit, ohm. So this completes the problem. So you got a 2.5 marks here in the section A, because the problem has been extended to the section B also. So what they have asked in the question B, see, if this combination is connected to a battery of EMF 10 volt. So what they are doing here, the combination, this combination of the resistances is connected to a battery of EMF 10 volt and negligible internal resistance, means a small r is negligible here. Now obtain the potential drop across each resistor. So in the section B, in the subsection B, what they have given, they have given E they have given, yes or no? EMF they have given, that is 10 volt, yes, and the internal resistance is negligible. Obtain the potential drop across each resistor, means in each resistor, in every resistor, what is the potential drop, means what is V in every resistor, because in the series combination the current I is same, current I is same for all the resistors, but the V, because between these 2 points we have V1, between these 2 points we have V2, and between these 2 points we have V3. So we have to find V1, V2, V3. So what you have to find here, what is V1, what is V2, and what is V3, we have to find. Okay, so what is the formula we are going to use? I hope you have understood the problem. They have told that the combination is connected to the battery of EMF 10 volt, and in such a condition we have to find what is the value of potential difference, means what is the value of V for every resistor we have to find. Okay, now I will remove this question. Now see here, they have told to find V1, V2 and V3 in this problem. Okay, so here you know already from the Ohm's law you have one formula, means V is equal to IR is the standard formula which you got from the Ohm's law. Okay, so now in this problem you have to find V. We have to find V for every resistor. You have to find V for every resistor. Hence, for that you need I and you need R. You know R already, because R is what? Effective EMF. R is 9 ohm. 9 ohm means related to this combination you have the R already. So RS is already you have it already. Okay, now what is I? What is the current flowing through this combination? You don't know that. So how to find I first? So to find I also you have formula, that is I is equal to V by R, from this only, by this only. Okay, so when in the combination when you get a battery and its EMF, so this EMF is nothing but the what? EMF is nothing but energy produced, that is nothing but the EMF, that is nothing but the potential difference, means in the place of V you can use E. So what is the formula you are going to use there? I is equal to V by R and V is equal to I into R. These two formulas you are using. So now start calculating in the calculation. So first you have to find I. Before going to find the V1, V2 and V3, you should find I. So what is the formula to find I? V by R. V is nothing but the EMF I am taking. EMF is 10 volt. So 10 divided by 9. 9 is RS, effective resistance of the combination. So it is nothing but 1.1 ampere. So you got I now. I is what? 1.1 ampere. Now by using this, can you find the V1, V2 and V3? Because V is equal to IR. Hence what is V1? I R1, because I will be remaining same for the series combination of the resistance, only V is changing. So V1, V2 and V3. So for this I R2, for this I R3. So now see, so V1 is I into R1. I is what? 1.1 into R1 is what? 2 ohm. So 1.1 into 2 is equal to 2.2 volt. This is potential difference. Next, V2 is I R2. 1.1 into 3. The second resistor is having a resistance 3. Hence it is 3.3 volts. V3 I R3, and the third resistor is having the resistance 4. Hence it is 4.4 volts. Hence you got all the three potential differences across each resistors: 2 ohm, 3 ohm and 4 ohm. Hence you got the result as V1 is equal to 2.2 volt, V2 is equal to 3.3 volt, and V3 is equal to 4.4 volt. This is the result you got. So now with this we have solved the problem of the question paper 2016. Okay, you can revise the problem. How? See what they have given. They have given the combination of three resistors which are connected in series: 2 ohm, 3 ohm and 4 ohm. First they have told you to find the effective resistance of this combination. For that you have the formula RS is equal to R1 plus R2 plus R3. By that you got RS is equal to 9 ohm. And they are continuing the question like this combination is connected to the battery of EMF 10 volt. So in such condition they have told you to find the potential difference across each resistor. Each resistor means for this resistor we have the potential difference V1, for this we have V2, for this we have V3, because you already know very well that the combination, when the resistors are in series combination, I will be same throughout each resistor, but the V potential difference will be changing for every resistor. This happens oppositely in the parallel combination. If the three resistors are in parallel combination, so in this condition the I is not same. If the main current is I, we have I1, I2 and I3, but V will be same. The opposite happens in this. So here we have only one current I and three potential differences. They have told to find the potential difference in each resistor. For that they have given the EMF E. By using EMF we have got I value. I value is 1.1 ampere. Hence since I will be same through the combination, we can solve the V1, V2 and V3 by the simple formula V is equal to IR. Hence we have got all the three resistances across every resistor. Okay, so this is the 2016 question. Moving on. See here. What they have asked in 2015. Theory questions, you know, you have went through it already. Okay, so see here. Again in 2015 we have got a 34th question. Okay, so what is the 34th question? See, two cells of EMF 2 volt and 4 volt and internal resistance 1 ohm and 2 ohm respectively are connected in parallel so as to send the current in the same direction through an external resistance of 10 ohm. Find the potential difference across 10 ohm resistor. This is a bit different than what all the problems we have solved so far. This is a bit different. See here what they have told. Try to understand it slowly. They have told you two cells are there, two cells, and they are having a EMF 2 2 volt and 4 volt, and they are having an internal resistance 1 ohm and 2 ohm. Okay, and those two cells are connected in parallel. Those two cells are connected in parallel, and the current, they are sending a current in the same direction through an external resistance. External resistance means capital R is 10 ohm. Means two cells are there connected in parallel, E1 E2 R1 R2. E1 is 2 volt, E2 is 4 volt, R1 is 1 ohm, R2 is 2 ohm, and the whole combination is connected to the external resistance R 10 ohm. Now we have to find the potential difference across that 10 ohm resistor, means which I am calling it as external resistance. In that external resistance, what is the value of potential difference? What is the value of V that we have to find? Now analyze the problem first. In this current electricity chapter, you can analyze the problem by drawing the circuit diagram, because you already know all these things which they asked in the problems are current elements, and you know how the connections will be for the cells, how they will be, you know, for the resistors, how they will be, you know. So you can analyze them very easily by the circuit diagram. That's why I keep on telling you, first try to analyze the problem. Okay, now two cells, okay, two cells, they are connected in parallel. They are connected in parallel. Okay. Okay, so they are having EMF E1 and E2, R1 and R2. What they have given here, the value of E1 is 2 volt, E2 is 4 volt, and internal resistance R1 is 1 ohm, R2 is 2 ohm. Okay, connected in the parallel combination, and an external resistance of 10 ohm. This combination is connected to an external resistance of 10 ohm. That external resistance is nothing but R is 10 ohm. Now we have to find the potential difference across this 10 ohm resistance. So here in this resistance, what is the value of V we have to find. What is the value of V here we have to find. Understood na? So this is how I have analyzed the problem. When you read the problem, you first try to analyze it. That gives you a way how to solve the problem. Okay, so now to find V, you have the means how to select the formula, that I am telling you now. To find the V, we have the formula I into R. V is I into R. But here we don't know I. Yes, we only know R. R is what? 10 ohm. The external resistance is 10 ohm. So we don't know I. So in such cases, while they are involving the cells, we know the formula of I. That is what? E divided by R plus R. In the case of cells, we use this formula. Na? So what you have to do, first you get the value of I by this. By this you get the value of I, because to find the E means, this E means what? Effective EMF. Effective EMF. You know the value of E1, you know the value of E2, you can find effective EMF. You know the value of R1, you know the value of R2, you can find the effective internal resistance, and R is already given to you. So by this you can easily find the value of I. So by after finding the value of I, substituting this here and substituting the value of 10 ohm, you can easily find V na. So this is how you get the way to solve the problem. So what is the formula we are going to use here? Two formulas we are using. First we are using I is equal to E divided by R plus R, and V is equal to I into R, and here EMF, effective EMF is there na, effective internal resistance is there, because you have R1, R2, E1, E2. So for this also you have a formula na. I have made a separate video for the expression for effective EMF and effective internal resistance. So this is a parallel combination. You go through that notes also. I have given the notes also. You go through that notes and you know the formula for the effective EMF in the parallel combination is E effective is E1 R2 plus E2 R1 divided by R1 plus R2. And the formula for effective internal resistance in the parallel combination is R effective is equal to R1 R2 divided by R1 plus R2. So by using these two formulas you find E and R. Substitute here, you will get I. Substitute that here, you will get V, which is the essential. Okay, so let's start now. Calculation. I hope you are observing. I am following all the steps in solving every problem. You too, if you too follow the same, it's much better. Okay, so now first we solve effective EMF. Okay, so E effective is equal to, what is the value of E1? 2. What is the value of R2? 2. What is the value of E2? 4. R2, R1 is 1 divided by R1 plus R2, 1 plus 2. 2 into 2, 4 plus 4 divided by 3. So it is 8 by 3 volt. Effective EMF is 8 by 3 volt. So now see what is effective internal resistance. R1 is 1 into R2 is 2, R1 plus R2. So effective EMF is 2 divided by 3 ohm. Effective internal resistance. So you got E effective and R effective. Okay, now so substitute here. What is, so I'll call this as 1, 2, 3. I is equal to, effective EMF is 8 by 3 whole divided by R is 2 by 3 plus 10. R, small r is 10. So it is 8 by 3 whole divided by 20, this is 2 by 3 plus 10 means 32 by 3 this is. So the calculation of this will give you the answer 1 by 4 ampere. So the value of I, the value of current in this circuit is I is equal to 1 by 4 ampere. So now you have a clear way to get the value for V, I into R. I hope all of you are solving along with me. If you only look at the video like a movie, it is not understood. You go on solving with me. Okay, so now V is equal to IR. You have got the value of I and you know the value of R. Now substitute 1 by 4 into 10. So it is 2.5 volt. Understood? So what we done here, we had a question that they have given in the question, they have given two cells and they have given EMFs and internal resistances, and they have told that the combination is connected to one external resistance of 10 ohm. This much they have given, and they have told to find what is V here in this external resistance R. So to find the V, we got a formula V is equal to I into R, in which we know only R, we didn't know I. So for the I, we have a formula E is equal to E divided by R plus R. So to get here, we should know E and R. So to find E and R, we had the components, means E1 and E2, R1 and R2 we had. That's why we found the effective EMF and effective internal resistance. For the parallel combination, we had these formulas. So by using them, we found effective EMF and effective internal resistance. Then we substituted them in this formula, E and R. And the R value which is already given, we are substituting, and we got the value of I as 1 by 4 ampere. So clearly after that, V is equal to IR formula we know already. So that is it. V is equal to 2.5 volt we got. Now it's time to write the result. So V is equal to 2.5 volt we got. Okay, so in every problem they will be given some hint to you. Means in this problem they have given a hint of E1, E2, R1, R2. So you have to think in this case why they have given these components and they have asked V. So they will not be asking, sometimes they will ask you indirectly. Means here they want V, but they have given these things. So you have to come in this way. Means you have to think of V first, V is equal to IR, then you have to go for I, then you have to go for E and R, for which you are using E1, E2, R1, R2. Understood? They will not be given everything directly, they will asking you indirectly. So you have to think of how to get the answer, means through which steps we can get the answer, you have to think. So to do all this, you will get 5 marks. Okay, so every problem they are asking for the 5 marks. So be serious about the problems. So far I have solved so many problems. Okay, so you go through all of them. I hope all of you are writing all the problems in a proper manner. You write all the problems which I have solved till now in a book. In a book along with your notes. You have the problems also, they are also of the equal importance. Okay, so after this, now I will stop this here. Okay, so what you do after this, means here by here I am ending with the chapter current electricity. So what is your work now is, you go through all the concept of current electricity chapter. You go through all the derivations, all the theoretical explanations, all the formulas, everything you go through. You see in any section, if you feel any doubt, or if you feel this part is a little bit complicated, you just contact me and you tell me that these things we have not understood, and you can explain us once again. If you want like that, I can engage one more class on the current electricity chapter for the coming week. Okay, so you go through all the concept, and wherever you feel it difficulty, you just tell me that. If you tell anything like that, I will engage one more class as a repetition, and after that we can start the new chapter. Okay, so and also if you get any other problems of this kind, and if you are unable to solve them, you can ask me. I will discuss it in one more class. Okay, so I am waiting for your replies. If you tell me about any concepts, about any part of this chapter, if you are feeling them difficult, you just tell me. I will repeat them. I will explain them once again for your convenience. This is one chance for you. Just utilize it. Okay, I will be waiting for your messages. If any of you, any one of you, if single person also ask me, I will repeat it, no problem. Okay, if any of you telling me the concept, the difficulties, I will explain them in one more class. So otherwise, if I not got any messages, any things, if I not got, I will start the next chapter from the next week. Okay, thank you. Be perfect in the current electricity chapter. With this, I am ending the current electricity chapter. Okay, thank you.